All right. Good morning, guys. Okay, let's start on 2.08. We did compound inequalities and the applications of inequalities on Wednesday, and you guys seemed okay with that. If does anybody want me to go back over that again? Okay. So that is the end of this week's work. So we will move on to literal equations as of now. Literal equations are, I don't know why they're called literal, but what they look like in general is just a bunch of letters. So something like this. And it will ask us to do something like solve for z or something like that. And this isn't really scary or anything. We know how to deal with all this. We just subtract it from one side. So minus 4z minus 4z. Anything we do to one side, we do to the other. This cancels out. So we're left with 6x plus 3y equals negative 4z plus 6. So now we're going to subtract the 6 over. Minus 6. So we're just kind of trading places with our z and our 6, or our 4z and our 6. So we end up with 6x plus 3y equals, minus 6 equals negative 4z. And now we just divide by negative 4. Negative 4, negative 4, negative 4. It cancels out right here. We end up with 6 over 4. 3 over 4. And then, and we can simplify these fractions, but that's not the point. The point is this is how we get z completely by itself. So it doesn't really matter what the variable is or what it looks like or what the problem looks like. We can get things by themselves a lot of the time. And this is useful for sometimes if we have an equation and we want it in a different, we want to find something different out about it. So for example, if we have y equals mx plus b, which is, if you'll remember, this is our slope-intercept form. This is for graphing lines. We have our slope right here and our intercept right here. So this is useful for when you have a slope and an intercept. But what if we want to find out what happens when we have everything but the slope? Well, for that, we need to find the slope. We need to get it by itself. So for this, we're going to want to try to get m by itself. So for that, we're going to subtract this b. Y minus b equals mx. And now we divide by x. So now we end up with y over x minus b over x equals m. And we have m by itself. So now we can plug in everything else and we can get m out, where we couldn't quite do that up here. So things like this are helpful when we're trying to get things in different forms and all that. We need to be able to just move things around and play with it a little bit, because sometimes that's helpful for later on down the road. So sometimes you have problems like, this is going to be one from your work. This is going to be number 9. So this is going to be one of the more difficult ones of the literal equations. S equals n over 2 times a plus t. Now I give my t the little curly tail just so you can tell it apart. And we want to solve this for a, meaning that we need a by itself. So the first thing that I'm going to do here is I'm going to multiply this n over 2 n. Actually, the first thing that I'm going to do is try to make it a little bit simpler. I'm going to try to get rid of this fraction here. I'm going to do that by multiplying each side by 2. So my iPad would work with me. This might be a little easier. So when we go to multiply everything by 2, we can just multiply this side by 2. And since everything on this side is multiplied by 2, we can just add the multiplied by 2 on the outside. And the reason that we're multiplying by 2 is because we have this fraction here. And we're undoing the fraction just by getting rid of this 2. So these will cancel out. And that's really all that's going to happen other than this 2 appears over here. So now we have something that's no fractions in the equation. 2s equals n times a plus t. And now this is something that we can do. We're still trying to get a by itself, but now it's a little easier. So now I'm going to distribute this in. We're going to end up with a times n plus t times n equals 2s. So this is still okay. Now what I'm going to try to do is switch the, actually I'm going to move this t of n over here. I'm going to do that by subtracting because it's added. So minus t times n is going to give me 2 times s minus t times n because we subtracted over here. And we're left with a times n. So now we're good to go. Now all we have to do is get this a completely by itself. So we're going to divide by n. And anything we do to that, we need to do to these. So these are going to cancel, and we're going to be left with a by itself. So now we have 2s over n minus, and we're looking at this, so we see that we have an n on top and an n on bottom, so these are going to cancel as well. So we can just have minus t equals a. So this can be our answer for something like that. And I know that this is a little difficult for those of you that are used to numbers and things like that, but the variables really aren't all that different from numbers. The letters, they just move around the same way that x does in all the ones that we've done before. You've just got a couple more of them. So I can work a few more of these, and hopefully that will clear up any more confusion that we have on this. And then we can move on to 2.09, which is the applications of literal equations. So if I have 2x plus 4w all over 3 equals z, then I can still solve this. So say we want to get w by itself here. So what something like this would look like on your actual work is it would say 2x plus 4w over 3 equals z, and you want to solve this for w. So that just means you're trying to get w by itself. So if we take this and we say, okay, well, how are we going to get w by itself? Well, the first thing I'm going to do is the same thing that I did last time. I'm going to try to get this fraction out of my problem so that way I don't have to deal with it anymore. And I'm going to do that by multiplying a 3 by each side. So by multiplying a 3 over here, by multiplying a 3 over here, I can cancel this fraction out. So I'm going to end up with 2x plus 4w equals 3z. I just switched sides. They're still the same thing. So these 3's canceled, and then this 3 just kind of appeared over here. So now I can work with this just like I've been working with it. So I'm going to move this x to the other side, minus 2x, because it's added in. So we need to undo it by doing subtraction. Minus 2x These are going to cancel out. And we are going to end up with 4w equals 3z minus 2x. Then we can divide by 4, divide by 4, divide by 4. And now we have w equals 3 over 4z minus 2 over 4 can simplify, so we can end up with 1/2 x. So we've now solved this for w, just like we were looking to try to do. So this is, I feel like this is fairly simple. So I'm going to move on to the applications of literal equations, and then I'll work a couple, and then you guys can work a couple. So that way maybe we can make a little progress instead of you guys spending time here and then going back to try to work on the applications as well. So let me get to it real quick. So these are going to be some more word problems. And word problems are, I feel like, something that this class or this teacher really likes. So we're going to work a couple of these from the works, from the 2.09 work. And hopefully by the end of it, you'll really have a good grasp of literal equations. So, okay. So just a little brain teaser to get you started. A number is multiplied by 7. So I'm going to write it down. And then the product is added to 13. The result is 55. What is the number? Okay, so the first thing that we need to do to work on this one is we need to ignore the question, what is the number? We need to just set the equation up, and then at the end we can worry about what the number is. So I'm going to start here at the back at this, the result is 55. So I'm just going to put an equals 55 because we know that that's what it's going to come out to be. So now I'm going to deal with this sentence before it, this one and this one. A number is multiplied by 7. So I'm going to call my number x just because that's usually what I'm going to go for. I'm going to say 7 times x, and then the product. So the product just means that we've multiplied things together, and then after that, the product is added to 13. So we need to add 13. So now we have an equation. So I'm going to write it a little more simply. 55 equals 7x plus 13. So now we can simplify this down to try to find what the number is. And we're going to do that just by getting x by itself, because x is the number. So, and we can do this by subtracting our 13 here. We're trying to get x by itself. And 55 minus 13 is, I believe, going to give me 32. I could be wrong about that. 55 minus 13, 42. That was off. Equals 7x. So now I'm going to divide by my 7. These are going to cancel. and I'm going to end up with 42 divided by 7, which is going to give me 6. So 6 equals x. So my number from up here is 6. So let's try number 3. I'm going to write it down, and then you guys give it a shot. So a number is divided by 4. And then the Okay, so give this one a shot. Just first off, just try to set up the equation. And then after you've set the equation up, let me know and we will talk about it. And if it's right, then we'll continue on to try to figure out what the number is. Okay, guys, do you have something?
I I got 25 equals x over 4 plus 17.
That's exactly right. So the way she got that is she said the result is 25. So we know that 25 equals whatever it is. So now we have the quotient, a number is divided by 4. So we're going to call our number x. We're going to say, okay, it's divided by 4. And then the quotient is added to 17, plus 17. So now this is good to go. So now let's try to work it and try to figure out what the number is. So work that, and then when you're done, say something, and we'll talk about it. Okay, do we have something?
I got x equals 2.
X equals 2. All right, let's see if that's right. So the first step in doing this is we have to go backwards in our PEMDAS, if you'll remember. So we're going to want to do addition and subtraction first. So we're going to subtract 17. This is going to give us 0. And this is going to give us 8. So now we have 8 equals x over 4. So now to undo our division, we multiply by 4. So we end up with 32 equals x. So what I think, to get 2, you would have divided again right here, and instead of multiplying, and gotten 8 divided by 4, which would have given you 2. But remember, to undo this, you need to do multiplication. So if we were to look at something like number 4, number 4 says on May 14th, 1898, a severe hailstorm hit Kansas City. The largest hailstones were 9.5 inches in circumference. I'm just going to put circ. Find the radius of one of the largest hailstones. The formula for circumference is C equals 2 pi r. So circumference just means how far around they are. So they were 9.5 inches from here all the way back to here. That was 9.5. What we want is the radius, which is this. It's the distance from the middle to the end. And we can do that just by solving this literal equation. So our radius is right here, and our circumference is right here. So the first thing that we need to do is get this where we can get radius by itself, because that's what we need to know. We already have circumference. So what I'm going to do is move this around. I'm going to, since all these are multiplied together, I'm just going to divide by 2 pi. 2 pi. This is going to cancel and this is going to cancel. End up with c over 2 pi equals the radius. So now I can plug in for what I know. I know that we have a 9.5 inch circumference. So 9.5 over 2 pi equals my radius. And I can plug that into a calculator. And I'm going to plug it in just like that. 9.5 divided by 2 times pi. Or I'll just use 3.14. And that will give me 1.512738, or just 1.51. So that means that if this is 9.5 inches, then this is 1.5 inches. So a lot of this stuff is going to be, if it gives you an equation of something and it tells you some information about it, but it doesn't tell you what it doesn't tell you the equation in the form you need it to be in. This gives you the ability to move the equation around and make it how you need it. So another example that I'll start and then you guys can finish is the formula for the area of a triangle is area equals 1/2 base times height. So 1/2 is multiplied by base times height. And so we want the area of a triangle with a base of 18 feet and 7 feet and a height of 7 feet. So base height. So try plugging this in and seeing what you get for it and seeing if it requires you to move anything around or anything like that. Okay, do we have anything?
I'm still trying to figure mine out.
Okay. Keep trying. Let me know when you get something.
I finished the equation. I don't know if it's right though, but I got A equals 63.
Okay, so let's give it a shot. So we have 1/2 times our base, which is 18, times our height, which is 7. So I'm going to plug those into a calculator. 1/2 times 18 times 7, which gives me 63. Perfect. So you don't really have to do any messing around with the equation to get this one to work. You just kind of plug the values in and that's great. And sometimes it works like that, but sometimes it doesn't. So for example, if instead of giving us base and height, it gives us area and base. So maybe it'll give us area is 28 and base is 8. So now we need to take this and move it around so that way we can get height by itself, because that's the part we don't know. So what we do for this is we're going to try to get height by itself, and then we're going to plug in our area and our base and see what height equals. So give this one a shot. This one's going to require a little more moving around than the last one did.